Hi everybody. Today we're going to talk about the angles associated with parallel lines. So I've shown a couple of lines L and M that I'm saying are parallel. And if you see a couple of arrowheads on a couple of lines that appear parallel, that's to indicate in fact they are. When a line crosses others, we often call it a transversal. I'm going to call this transversal T. And we're going to talk about lots of angles that are associated right here. Probably a good idea for you to pause the video and make a sketch like this one on your own paper. The first pair of angles I need to talk about are called corresponding angles. Let's make a note about that. Corresponding angles. I can give you a pair of those. Angle 1 and angle 5. This angle at 1 and this angle at 5 are corresponding angles. I think they're called corresponding angles because their positions correspond. And if these lines are parallel, I bet you're going to agree with me, but this angle 5 and this angle 1 are in fact congruent. Corresponding angles are congruent when lines are parallel. We're going to accept that by postulate. A postulate is an idea that is so obvious that we can accept it without proof. And we're going to accept this one without proof, that corresponding angles are congruent when lines are parallel. Let's name some other corresponding angles from this figure. Angle 2 has a corresponding partner, and it's by virtue of their positions, angle 2 and angle 6 correspond. They would also be congruent. How about angle 4? Has it got a corresponding partner? It does. Angle 4 corresponds with angle 8. And if those lines were parallel, angle 4 and angle 8 would also be congruent. Another pair of corresponding angles could be angle 3 and angle 7. Another pair of angles that you'll need to know about are called alternate interior angles. When we use the word alternate, that means they're going to be on alternating sides of the transversal. And when we say interior, that means that they'll be between the parallel lines. There'll be two pairs of alternate interior angles. For example, angle 4 and another angle will be alternate interior angles, and that would be angle 6. When you study angle 4 and angle 6, you realize they're on opposite sides of the transversal. They're alternate angles, and they're interior between the parallel lines. Another pair of alternate interior angles would be angle 5 and angle 3. Turns out that alternate interior angles are also congruent, but we're not going to accept that by postulate. We're going to prove that, just not right now. But I do confirm that alternate interior angles will be congruent. But the angle 8 and angle 4, which look to be congruent, in fact are congruent. Another important pair of angles that we'll need to discuss with parallel lines are called same-side interior angles. You can probably figure out what I'm talking about there. To be same side, they're going to be on the same side of the transversal. And to be interior, they're going to be between the parallel lines. An example I could give you would be angle 4 and angle 5. They're not adjacent. They don't share a common ray. They're not adjacent, but they're on the same side of the transversal, and they're also interior angles. What relationship do you think angle 4 and angle 5 would have? We ought to talk about that. Actually, let's do that right away. If angle 1 is congruent to angle 5, and angle 1 and angle 4 are a linear pair, therefore they're also supplementary, I think it makes sense that 5 and 4 would also be supplementary. If 1 and 4 add up to 180, and 1's as big as 5, makes sense to me that 5 and 4 would also add up to 180. So we should know that same-side interior angles will be supplementary. I'm going to make that note. When we were talking about alternate interior angles a moment ago, I did say that they would be congruent with one another, and it makes good sense that they would be. Check this out. If angle 1 is congruent to angle 5, because we know those are corresponding angles, and we accept them to be congruent, isn't it true that angle 1 is congruent to angle 3? Because those are vertical angles, and vertical angles are congruent. So if 1 is congruent to 5 because they're corresponding angles, and 1 is congruent to 3 because they're vertical angles, we can see that angle 5 and angle 3 would be congruent, and those are the alternate interior angle pair that I was talking about. So we'll be proving those things later. Let me show you another pair of angles that could be important to us. Another pair of angles we could talk about are alternate exterior angles. I bet you could figure out a pair of those if you wanted to on your own. Alternate exterior angles, the alternate says they'll be on opposite sides of the transversal, and exterior means they'll be outside of the parallel lines. I could come up with a pair like that, alternate exterior angles, angle 1 and angle 7. Likewise, for alternate exterior angles, angle 8 has an alternate exterior partner, that'd be angle 2. What relationship do you think those angles would have to have? I'm thinking about like angle 8 and angle 2. I know that angle 2 is as big as angle 4 because vertical angles are congruent, and likewise 8 is as big as 6. But we've already decided that 6 and 4 were congruent to each other. So if 2 is congruent to 4 and 8 is congruent to 6, but those are congruent as well, we can assume that 8 and 2 are also congruent. So you're going to want to remember that alternate exterior angles are also congruent. What about same side exterior angles? Well, they have to be on the same side of the transversal and be outside of the parallel lines. Let's name a pair. Angle 2 and angle 7. Another pair of same side exterior angles could be angle 1 and angle 8. What relationship do you think they would have? Angle 1 and angle 8. It's pretty obvious to me that angle 1 appears to be obtuse, angle 8 appears to be acute. They're not going to be congruent, but those are another pair of supplementary angles. There's lots of reasons you could figure that out. I know that 8 and 5 are supplementary, and I know that 1's congruent to 5 because they're corresponding angles. And if 8 and 5 are supplementary and 1's congruent to 5, wouldn't 8 be supplementary with angle 1? You can depend on same side exterior angles being supplementary as well. Now, let's look at this page. It's going to show me some angles and ask me to make some decisions about them. We'll understand that L is parallel to M. That's what this message says. Use this figure and answer these things. We'll name a pair of angles and you will tell the name of the pair of angles and what relationship they have. Angle 3 and angle 5, angle 3 here, angle 5 there, are alternate. I'm going to abbreviate this. Interior angles. And the relationship that alternate interior angles have, like angle 3 and angle 5, they must be congruent. And we can abbreviate it just that way. Angle 1 and angle 5, if you're looking at that pair, 1 and 5, those are corresponding angles. Their positions correspond. And what do we know about those? They must also be congruent. Next, we're going to look at angle 7. Here's angle 7 and angle 1. They're on opposite sides of the transversal, and they're not between the parallel lines. They must be alternate exterior angles. I'll make that note. Alternate exterior angles. And I think it's fair to abbreviate things like that. That's going to mean alternate exterior angles to me. And what about those alternate exterior angles like angle 7 and angle 1? Yep, they got to be congruent, don't they? What about angle 6 and angle 3? Here's angle 3, here's angle 6. Those are same side interiors. They're between the parallel lines on the same side of that transversal. We're going to call those same side interior angles. And the relationship that they hold, they must be supplementary. Now, we're going to look for another example of each of those. Ask for alternate interior angles again. Now, I've already used 7 and 1 for alternate interior angles. Oh, those were alternate exteriors. Alternate interior angles, I've used 3 and 5. I don't want to use 3 and 5 again. To use another example, that would be 4 and 6. Angle 4 and angle 6 are another example of alternate interior angles. It asks for another example, please, of same side interior angles. I got to figure out which one did I do already with same side interior angles. And that was 6 and 3 were same side interiors. Another pair of same side interior angles would be 5 and 4. Looking for another pair of corresponding angles. The last pair of corresponding angles we knew about was angle 1 and 5. And if 1 and 5 are corresponding angles, give me another pair of corresponding angles. There are lots of them. How about angle 2 and angle 6? Alternate exterior angles. Let's see if we got a pair of those already. We did. Angle 7 and angle 1 were alternate exterior angles. Is there another pair of alternate exterior angles? And I say yes, there is. It'd be angle 8 and angle 2. Now that we've seen those ideas, you'll see that we can write lots of interesting little equations and figure out the measures of angles. So first off, we're studying this figure, and it talks about angle 4 and angle 6. And it gives me these expressions, 4x plus 10 and 7x minus 14. I wouldn't even worry about those until I think about angle 4 and angle 6. What kind of angles are 4 and 6? In fact, it asked me those questions directly. Those are alternate interior angles. I'll make that note. Alternate interior angles. And because alternate interior angles are congruent when lines are parallel, I know that 4x plus 10 must be the same as 7x minus 14. Because I know the measure of angle 4 must be the same as the measure of angle 6. I'll subtract 4x from both sides, and I get 10 is equal to 3x minus 14. Add 14 to both sides, that makes me think that 24 is equal to 3x. So I'm convinced that x is equal to 8. Now that I know that x is equal to 8, I've got to find the measures of those angles. What kind of angles are these? Well, I've got to figure that out. What's the measure of angle 4? Since x is equal to 8 and 4 times 8 is 32 plus 10, I guess that'd be a 42-degree angle there. Well, I'm supposed to give the measure of angle 4, 5, and 7. That's what I'll do. The measure of angle 5. I do know that angle 4 is 42. Let me go ahead and figure out about the measure of angle 7 as well. Maybe I can go back and figure out about 5 in a moment. The measure of angle 7? I should get the measure of angle 6 first. I apologize. Let me look at the measure of angle 6. Since x was equal to 8, 7 times 8 is 56, minus 14, that'd also be 42. Now that I know angle 6 is 42, can I figure out about angle 5? And since those make a linear pair, you could have also thought that these angles were supplementary. Those have to add up to 180 also. So if I take that 42 out of 180, I'd be left with 138 degrees for angle 5. And I can figure those out. Let's check out another pair. This talks about angle 1 and angle 5 in the same picture. And you would recognize that angle 1 and angle 5, they're corresponding angles. I should make that note. Corresponding angles. And we know that corresponding angles are congruent, so angle 1 and angle 5 should be equal in measure. Let's set that up. That should tell me that 10x is equal to 6x plus 48. When I subtract 6x from both sides, I'll have 4x equals 48. And I'm now convinced that x is equal to 12 as I divide both sides by 4. I'm going to go find out the measures of 1, 5, and 8. But first off, the measure of angle 1, since it says it's 10x and x is equal to 12, angle 1 will be 10 times 12, 120 degrees. What about the measure of angle 5? Well, angle 1 and angle 5 are corresponding angles, so 5's got to be as big as 1 is. And 6 times 12 is 72 plus 48. Yep, that's another 120. But I'm also asked for the measure of angle 8. As I study this figure, and I know that angle 5 is 120, angle 8 is the supplement of angle 5. They make a straight line together, and the supplement of 120 has to be 60 degrees. We're going to work several more like that. You might be ready for the exercise, but let me do a few more. In this figure, we have lines L parallel to M and the same kind of angles. But it talks about right away angle 4 and angle 5. So looking at this pair of angles, 4 and 5, before I worry about writing any kind of equation, I got to think what relationship those two angles have. And angle 4 and angle 5 are same side interiors. You got to be remembering what's true about same side interior angles. They've got to be supplementary. So we should know that these two measures should add up to 180 degrees. These angles that don't appear to be congruent, they're not. I know that angle 3 and angle 5 would be congruent, but angle 5 and angle 4, they're going to be supplementary. So I'll say that 10x plus 5 plus 20x minus 5 equals 180. Same side interior angles are supplementary. Gather like terms, and we have 30x plus 0 equals 180. Positive 5 and a negative 5 gave me that 0. I can drop that. Divide both sides by 30, and I'm convinced that x is equal to 6. I should tell you about the measures of angle 4, 5, and 7. I'll do the measure of angle 4 first. Since x is equal to 6, angle 4 would be 10 times 6. There's 10 times 6 is 60 plus 5. There's 65 degrees. Now I seek the measure of angle 5. Angle 5 is the supplement of angle 4, and the supplement of 65 has to be 115. I know that these angles should be supplementary. I'm also asked about the measure of angle 7. I'll do that now. Angle 7, why, angle 7 is the vertical pair with angle 5, so it must also be 115 degrees. I'm not sure we have to do all of these together, but I think I'll just keep on going and work a couple more. Same figure, but this time it talks about angle 1 and angle 7. You might be looking at angle 1 and angle 7 as well. What kind of angles are these? Why, those are alternate exterior angles. And we ought to be thinking that alternate exterior angles like 1 and 7, they're going to be congruent to each other. Therefore, these things must be equal in measure. The equation ought to be 10x plus 40 equals 20x minus 50. Let's gather like terms and see what comes. I'll subtract 10x from both sides, which would leave 40 equals 10x minus 50. Bring that negative 50 to the other side, I'll have 90 equals 10x. Divide both sides by 10, and I'm convinced that x is equal to 9. That's all fine and dandy, but I gotta go find the measures of angle 3, 4, and 5. I better figure out about the angles that I'm given here first. What about the measure of angle 1? If x is equal to 9, angle 1 would be 10 times 9 is 90 plus 40, 130 degrees. I'm going to find out about the measure of angle 7. I think that'll be helpful as I seek 3, 4, and 5. The measure of angle 7, if x is truly 9, 20 times 9 is 180 minus 50. Yep, that's still 130. I know those alternate exterior angles should be congruent. So now I can work on angles 3, 4, and 5. The measure of angle 3. Angle 3 is congruent to angle 1. Those are vertical angles, and we knew that angle 1 was 130. So I'll report that angle 3 is also 130 degrees. The measure of angle 4 is the next one I got to come up with. Where's angle 4? Well, angle 4 is the supplement of angle 3. I see that they make a linear pair together. And if angle 3 is 130, then 4 must be 50 degrees. So you got to remember all the things you know about angles to figure this out. And we can get the measure of angle 5 as well. Angle 5 is congruent to angle 3. For one thing, they're alternate interior angles. If that's 130, angle 5 is 130. I'm sure there are other ways you could figure that out. Why don't you pause the video and do this next one before I do it. I hope when you looked at that figure, looked at angle 4 and angle 8 before you did anything else. Angle 4 and angle 8, let me bring the figure over here, 4 and 8 are corresponding angles, so I made that quick note. And because they're corresponding angles, I know that they would be congruent when those lines are parallel. So I say that 8x plus 2 is equal to 12x minus 18. And I'll solve that equation. Gathering like terms, we get the x's together first. I'd subtract 8x from both sides. I'm left with 2 equal to 4x minus 18. Add 18 to both sides, and I got 20 equals to 4x. And that convinces me that x is equal to 5. I'm supposed to figure out about angle 4, 8, and 1. I do know about angle 4. I can work on that. I'll find the measure of angle 4. Since x is 5, 8 times 5 will be 40 plus 2. Angle 4 should be 42 degrees. The measure of angle 8. Well, we're given that 8 is 12x, so 12 times 5 is 60 minus 18. Hey, there's 42 again. That's good, because 4 and 8 were supposed to be congruent as we study this figure. Angle 4 and 8 were corresponding angles. They've got to match up. I've only got one more angle to figure out about here. I should find out about the measure of angle 1. To do that, I've got to study how does 1 relate to the other angles I know about. I knew about angle 4, and angle 1 and angle 4, don't they make a linear pair together? Therefore, they're supplementary. Angle 1 must be the supplement of angle 4, or angle 8. So if the supplement of 42 be 138 degrees. I don't really think you got to watch me work these last couple. Oh, let me work this next question. It is a beautiful thing. Look, it's got a quadratic. Let's do that indeed. We should do that one. First off, we'll look at angle 4 and angle 5. 4 and 5, well, those are same side interiors, aren't they? So we know that they should be supplementary. What kind of angles are these? Those are same side interior angles. And I know that same side interior angles got to be supplementary, so I know that these should add up to 180. Let's write that equation. X squared plus 5 plus 5x plus 25 adds up to 180. There's lots of steps we go through to solve a quadratic equation. First, we're going to clean up the left-hand number. It becomes x squared plus 5x, and put the 5 together with the 25, and that's going to give us 30, equals 180. Whenever you solve a quadratic equation, under all circumstances, you're going to set it equal to 0 first. To set this equal to 0, I've got to subtract 180 from both sides. It becomes x squared plus 5x minus 150 is equal to 0. Now we're going to set up to factor this thing. I know the factors of x squared will fall here and here, but then I've got to find the factors of 150, and they'll fall here and here as we seek to solve this quadratic by factoring. You could use the quadratic formula, but this is a very nice way of doing it. So as I seek the factors of 150, it could be 25 and 6, could be 15 and 10. And because this middle term is 5x, actually it's going to be the 15 and the 10. I know the last term times the last term gives me that 150, so one of those has to be negative, but check how that middle term comes. The first term times the first term gives me x squared, and we needed that. But the outside terms gives me 10x, and the inside terms, if we were to multiply these, gives me 15x. If I want to keep that positive 5, I'll have to have a plus on the 15 and a minus on the 10. You should carefully multiply these and see when you multiply them, would you get this back again? I'm convinced you would. X times x gives us x squared. Outside terms give me a negative 10x. The inside terms give me a positive 15. A negative 10 and a positive 15 leave that with 5x, and last times last is a negative 150. So I know that this is proper factorization of this quadratic. Let's work on that. You should remember that the product of two factors is equal to 0, then one of those factors must be 0. So I'm thinking x plus 15 could be 0, could be equal to 0, or perhaps x minus 10 could be equal to 0. Lots of simple things to think about here. X should therefore, in this case, be equal to negative 15. I'm not sure that's going to be the principal root. If I add 10 to both sides of this equation, I see that x is equal to 10. Let's look at this negative 15 and see what you think. The measure of angle 5 would be, well, 5 times a negative 15 would be a negative 75, plus 25 would be a negative 50 degrees. We're not going to have any negative degree angles. I'm not going to get an answer out of that. The principal root must be x equal to 10. Truth is, I don't mind x being negative. I just want to allow an angle to have negative measure. But if x is equal to 10, let's find out about the measure of angle 4. And it's 10 squared. Since x is equal to 10, 10 squared, 100 plus 5 would be 105. And I want to find out about the measure of angle 5 as well. X being 10 would be 5 times 10. That's 50 plus 25, that'd be 75. Now, is that appropriate? Could angle 4 and 5 be 75 and 105? I thought, yeah, that's really good because they should add up to 180. And 75 and 105 do. But I'm supposed to find out about angle 6, 1, and 3. Oh my goodness. Let's find out about the measure of angle 6, the measure of angle 1, and the measure of angle 3. Pretty good question here. Glad I didn't skip it. I got to remember that angle 4, now my picture is not drawn to scale. Number 4 does not look like 105, but that's just what happens here. And angle 5 is supposed to be 75 degrees. So if angle 5 is 75 degrees, I know angle 1 should be the same amount because angle 5 and angle 1 are corresponding angles. So angle 1 must also be 75 degrees. 5 and 1 are congruent corresponding angles. What about angle 6? Well, what do you know about angle 4 and angle 6? Angle 4 and angle 6 are alternate interior angles. We knew that angle 4 was 105, so angle 6 should be 105 as well. Then I got to find out the measure. I got to find out the measure of angle 3. How does 3 relate with anything else? I see that angle 3 is the vertical partner with angle 1. And if I know the measure of angle 1, that'll be the same as the measure of angle 3. And we've already found the measure of angle 1 to be 75, therefore angle 3 should also be 75 degrees. Now that's a pretty good question after all. You'll have an assignment sort of like this one to work on. Tell me if you need some help with it. We'll be talking about it. Do your best. Thank you.